Push, we are recording. You want to say hi to Mom? All right, here we go. All right, so adding rational numbers with different denominators. Look, honestly, guys, don't let fractions freak you out. All right, don't go spastic over fractions. They really are not hard, and there's really only a few things you have to do in order to be able to solve them. So just relax, think it through, learn your rules, and everything's fine. So one, to add fractions, they must have the same denominator. You got to have the same denominator. Well, here's what gets students a little bit. To multiply them, do they need the same denominator? No. To divide them, do they need the same denominator? No. But to add them, you got to have the same denominator. But it's not a big deal. And over the weekend, you guys added a bunch of them, and they already had a common denominator. So it was real easy. Add the numerators, put them over the common denominator, and of course, that's what the rule is, right? So here in this one, I'm giving you both rules at once by using the plus minus, right? Whether we're adding or subtracting, you take the first numerator and add it or minus it from the second numerator and put it over that common denominator, right? A plus b over x or a minus b over x. We had both of those rules already on Friday, right? A plus b over x or a minus b over x. How many on your homework you missed one or less? Okay, bunch of you. And that should be the case. Those should have been easy, and hopefully that was an easy assignment. Just got to be careful with your positives and negatives, but again, a lot of you are really good. John, close that door for me. We're getting ready for the lunch rush. All right, so hopefully that's the case. Well, there are many common denominators. There are many common denominators, but the best common denominator is the one that uses, anybody know? It's something we've learned already. Yes, the LCD, exactly. You know, we did LCMs, right? Least common multiple, and when we were learning the least common multiple, I showed you guys some LCDs, and the LCD is the best one to use. All right, well, if you look at this example here, we've got 1/6 and we got 3/4. So there are a lot of common denominators. For example, 24 is a common denominator. You can get both of the denominators to be 24. It's not so hard. I gotta take that off my ear, man. It's driving me crazy. It's too good of a ear muff. I mean, I should use these at home when somebody's snoring. That might work. All right. 24 is a good denominator, but it's not the best common denominator. And there are more. 36, right, is a common denominator, but it's not the lowest or least common denominator. 48 is a common denominator, but not the least common denominator. 60 is a common denominator, but not the least. And I could go on forever because there's an infinite number of common denominators. Okay, so a lot of you already, I picked again an easy example, and remember, we're learning concepts on easy things so we can do them on harder things, right? So don't short circuit the teaching by just saying, oh, okay, I already know the common denominator is blah, blah, blah. All right, don't short circuit the thinking. On things where you don't know the common denominator, then you figure it out using the way we figured out LCMs or the LCD. So if you remember, what did we do? We factored the denominators, right? A 6 is a 2 times 3. And a 4 is a 2 times 2. Now, I didn't even bother to write the numerators there because does it matter what's in the numerator? It doesn't matter one bit. So I'm not worried about that. I'm looking at the denominators. So if you remember how to do the chart, I'm going to put a 2 in the first box, but I'm going to skip a box, right? Because I see the 2 2s below and put the 3 down there. So use your red for a 2 and a 3, and use your blue for the 2 times 2. So somebody raise your hand and tell me how to fill in the last row here. Gabe, what's the last row?
2 times 2 times 3.
Exactly, right? Every row gets represented once for the LCD. And remember, you got to keep that straight from the GCF, right? And the LCM, they were two different things. So this is 2 times 2 times 3. And if we multiply that out, we would all get A. And there's our common denominator. And again, it was an easy one. Hopefully you knew that the lowest common denominator was 12 right from the beginning. But it is the lowest common denominator that you want. All right, so now, how do you use the LCD? Right, I'm looking right here at this line. How do you use the LCD to get that common denominator? Well, it's really, really simple. And I'm going to show you on an easy one so you can do a complex one. And down the road next year in Algebra 2, we'll have some really complex things. We'll have variables and everything. And it won't be that big of a deal because we'll know the concept. So here's simply the concept. On the 1/6, I'm looking at this 1/6, right? And here I am right here. And the 6 is a what? It's a 2 times 3, right? Well, what of the LCD is the 2 times 3 missing? Isn't it missing this 2 right there? Well, the thing it's missing is what you have to multiply it by. Doesn't that get you a 12? I mean, this is how you figure it out when it's not something that's easily known just by simple numbers. Now, when you look at the 4, what is the 4 missing out of the LCD? It's missing the 3, right? And so what will we multiply it by? A 3 on the bottom. And you guys know I'm using the arrows, right? Because we've already learned whatever you do to the bottom, do the same thing to the top, right? And it's the bottom where you start because it's the bottom that you're concerned about. Okay, so let's figure out where we're at. Right now we're at 2 over 12. Hopefully you agree. Plus 9 over 12. And hopefully you agree. Again, if I make a mistake, don't drink the Kool-Aid. Let me know, right? Okay, so what's going to go in the box? The rule step. Look, what am I trying to do with the rule step? I have all the confidence in the world that you can add 2 and 9 in your head. That's not my concern. But here's the thing. Today we're adding fractions or subtracting them. And later on in the week we're going to multiply them, and later on in the week we're going to divide them, and we got to keep it straight. And I need your mind to keep it straight. But look, I don't need your mind to keep it straight just for this week or next week when your test is. I need you to keep it straight 2 months from now when we run across another fraction problem and we haven't done fractions in a month. And I need you to keep it straight 6 months from now when we run across a fraction problem. And I need you to keep it straight next year for when we run across a fraction problem. And I need to keep it straight when you're a junior or a senior and you take the SAT or ACT to get into college. And I need you to keep it straight when you're a sophomore and you take the PSAT to see how you're going to do on the SAT, ACT. Got it all? You follow? So by trying to make you write the rule step every time right now, I'm trying to get it stuck in your brain that that's what you're doing. So that's the only purpose. So just hang in there. Once we're done with fractions, I won't ask you to write the rule step anymore. But right now, while we're doing them, I want you to write the rule step so you get that rule stuck in your brain. All right, so that's obviously a 2 plus 9 then over the 12, right? That's the rule step. You're showing adding the numerators, putting them over the common denominator. And of course, we all know to finish that as 11/12, right? Not hard. That's not hard. You guys can all do that. So let's go through a bunch of examples. All right, so number 3, hey, this is a pretty simplistic problem. I want you to notice something about the denominators. What is common between a 5 and a 3? They're both some kind of something. Andrew? They are odds, that's true. I'm looking for something else, but that is a true fact. They are both odd. Jordan? They're both prime numbers. Whenever you have prime numbers, you don't need to go through a big deal of figuring out the LCD. Because you know what the LCD is always when you got prime numbers? It's always the 2 multiplied together. So watch. What is the 5 missing? The 3. Whenever they're prime numbers, it's always that easy. The 5 is missing the 3. Because what's the LCD going to be? Somebody say it if you know it. What's the LCD? 15, right? And a 5 times 3 is 15. Whatever you do to the bottom, do the same thing at the top. And what are we going to multiply the 3 by? The other one, the 5, right? Now, again, remember, we're just looking at the denominators right now. I could care less what's in the numerator. And whatever I do to the bottom, do the same thing to the top, right? Okay, so let's keep rolling here. So now what do we got? A 9 over 15. By the way, some of you guys, your times tables aren't the greatest, and that's what's giving you some issue. So sharpen up your times tables. Really, honestly, I can't help you. If you can't do the times tables by the time you get to me, there's nothing I can do to help you. Now, you can help yourself. You got to go back and learn them. If you short-circuited learning your times tables, you got to go back and learn. You got to do that. And my advice is over Christmas break, you better go practice your times tables. Now, these days there's lots of stuff online where you can practice, but you better get your times. Ask mom or dad to get flashcards and practice because you got to know your times tables. And that's just basic stuff. All right, and then the other one is what? 10/15. And now what are we ready for? Class, we're ready for the rule step. Awesome. Because again, I'm trying to train your brain, right? Okay, so 9 and 10 is 19, and we're done 19/15. I'm going to leave it as an improper fraction because we didn't have mixed numbers to begin with. So I'll just leave it as an improper fraction, and we're ready to roll. Hey, that wasn't hard. Was that hard? No, fractions are easy if you know what you're doing. Fractions are easy. All right, next one. So again, I look at this one, and 6 is not prime, is it? But 5 is. Well, keep getting that lower one. 5 is. You don't need to do that in your notes. But then I look at the 6. Can't we all factor 6 in our head? Does 6 have any 5s? No, so it's just like they're both prime because there's no 5s in 6. So again, this is an easy one. You don't necessarily need to go through the whole LCD thing. What are you going to multiply the 6 of the first one by? Say it if you know it. 5. And whatever you do to the bottom, do the same thing at the top. And what are we going to multiply the 5 of the second one by? 6. And whatever we do to the bottom, do the same thing at the top. All right, you guys finish that one off. Let's see what you do. Go ahead and try to finish it. Let's see if you get it correct. All right, say your answer on 3. 1, 2, 3. All right, and I heard a lot of negative 53 over 30s, right? 35 negatives and 18 more negatives, 53 negatives, negative 53 over 30. How many got that correct? Okay, good. Fractions, adding fractions are not hard, but you got to remember you need a common denominator. On this next one, it's pretty simplistic. But again, maybe you wouldn't know how to get the LCD. And hopefully you're going to say a 4 is a 2 times 2. And a 6 is a 2 times 3. And there we are right back to that 2 times 2 times 3. So again, pretty simplistic. I'm not saying you need to do this, by the way, on simplistic ones. Okay? You don't need to show the chart of the LCD on ones you can do. All right? I'm just making sure you know what to do if you don't know what the common denominator is, the lowest common denominator. Okay, so what are you going to multiply the 4 of the first one by? Say it if you know it. No. By 3. You're trying to get it to a 12. What's it missing? The 3, right? Whatever you do the bottom, do the same thing at the top. What are you going to multiply the 6 by? 2. What it's missing. Whatever you do the bottom, do the same thing at the top. Okay, go ahead and finish that one off. See what you get. All right. Most of you guys are done on 3. Give me your solution. 1, 2, 3. All right, good. Heard a lot of negative 19s over 12. All right, so go ahead and do 6 all by yourself. Go ahead and do 6. Start, finish. Did yours reduce? Can you factor the top, though? You can. It's all 3's, right? Can you factor the bottom? Hey, you know what the bottom factors into? It factors into 2 times 5 times 7, right? You know what the factors of the bottom are. Are there any 3's in a 2 times 5 times 7? No. So how many got negative 27 over 70? All right, good. If you didn't, where's your mistake? Find your mistake. All right, is it in the multiplication? Were you going for 70? 70 is the lowest common denominator. If you don't use 70, you're going to have to reduce. So I did the LCD, 257. What was the 35 missing? The 2. So I multiply by 2 over 2. What was the 10 missing? The 7. So I multiply by 7 over 7. Be careful with your pluses or minuses. So how many got that right again? Let me see. Okay. And the rest of you, questions. Questions on why? Any questions? Any questions? Kirsten. You always reduce. You always reduce when you can. Always. Always. All right, let's go to the next page. All right, so now students start freaking out. Oh no, there's a mixed number. There's a whole number in a fraction. Oh my. Lions and tigers and bears. All right, what is the denominator of the 3? All right, so big deal. All right, so who cares? There's a 1 under there. I would have done that in red if it would have come out red. Right, so big deal. So there's a 1 underneath the 3. Look, in actuality, this is an easy kind. Right? Can you get a 1 to be a 7? Yeah, real easily. Just multiply it by 7 on the bottom. And whatever you do to the bottom, do the same thing to the top. All right, so look how easy this thing really is. So what is the left? A 21 over 7 plus a 5 over 7. Rule step, 21 plus 5 over 7. Final answer, 26 sevenths. And that's it. Those are really easier when you get a whole number mixed in there. It's got a 1 on the bottom. You're always going to use the other denominator as the common denominator, right? Wasn't the 7 the common denominator? Easy to get a 1 to be a 7. Those are really kind of easy. Don't let those scare you. They're easy. All right, next one. Same situation, right? So go ahead and solve that one. Go ahead and do 8A, see where you end up. All right, nice and loud on 3 if you've got an answer. 1, 2, 3. That was 3 in German, all right? 37 over 5, right? I heard a ton of that. All right, sorry if you're German. I know the pronunciation was probably horrible, but 37 fifths, right? No problem. We're going to get a common denominator. Look, in all of these, you're looking and saying, oh, I'm adding fractions. What do I need when I add fractions? I need a common denominator. And then what do? Add the numerators and put them over a common denominator. That's not a lot to remember. It's really not. You look at adding fractions and you say, oh, got to have a common denominator. Once I get it, add the numerators, put them over the common denominator, and you're done. All right, so now you look at this and you see 2 mixed numbers. And that may concern you there in seeing those 2 mixed numbers, but don't let that concern you. See if I can get high enough to get, all right, can't get to my shade. Shade, where are you? Let's go this way. Whatever. All right, I won't worry about it. You know, you look at it and you say mixed numbers. So what? Somebody raise your hand. What do you think you're going to do with this situation? You look at it and you say, I'm adding 2 mixed numbers. Now, I'll be honest with you. This is an easy one. If you really understand positives and negatives, you can do this in your head. Anybody give me the answer in their head? I'm just curious. If you know how to add positive and negative numbers, and we do know, right? You should be able to do this in your head. Didn't the positive 3.5 wipe out 3.5 of the negative 4 1/4? Didn't it? So what's left? No, not 1.5. Negative something. All right. So, but look, doing them in your head, you got to be careful, and a lot of you gave the wrong answer. But look, we know we're going to do what to the mixed numbers? Say it if you know it. What are we going to do to the mixed numbers? Turn them to an improper fraction, right? So we're just going to change our mixed numbers into an improper fraction. I'm showing the step, right? Because it only takes a second, and it's going to help me to keep from making a mistake. 3 times 2 is 6. 6 and 1 is 7. So I have 7/2. By the way, watch what I'm going to do. I know I'm going to go for a common denominator, so I'm going to leave some space so I can do my math of my common denominator. 4 times 4 is 16, and 1 is 17. I have 17/4. The LCD is easy on this one, isn't it? Say it if you know it. It's 4. So all we have to do is multiply the front 2 by a 2. Whatever we do on the bottom, do the same thing on the top. Okay, the rest is just being careful. I have a 14/4 minus a 17/4. I will show the rule step. 14 minus 17 over 14. Oh, I'm sorry, over 4. That 14 got stuck in there. Who was drinking the Kool-Aid? Man, oh man. All right. So I'm going to go right because I'm running out of room there. So what do you end up with? A negative 3/4? Right. So look, that's not hard. We can do that. All right, the last one I chose to refresh your memory on being careful with these negatives. Remember, converting this, do a negative and do a parentheses, right? And then the 5 times the 8 plus the 1 is the whole top of that. Right? That's how we convert them when they're negative, over an 8. And then the other one is positive, so that's easy. 3 times 6 plus 5 over a 6, right? Is everybody okay with that? So what's the left numerator? What do we get for a left numerator? And hopefully you say a negative 41, right? Negative 41 over 8. Now again, I'm going to leave some space, right? Because here, I'll put it higher for you guys. I'm going to leave some space because I need to get to a common denominator, right? So leave some space, do the plus sign. And what is the right? 18 and 5 is 23, so 23/6. Now, some of you already know the LCD. If you don't, then figure it out using the chart. Who can tell me what the lowest common denominator is, Nick? It is 24. So if you use 48, 48 will work, but then you have bigger numbers and you got to reduce and you have more capability to make a mistake. 24 is best. If you don't know how to do it, use the chart. We already know how to do the chart. So how do I get an 8 to be a 24? I multiply it by 3. Whatever I do on the bottom, do the same thing on the top. How do I get a 6 to be a 24? I multiply it by a 4. Whatever I do on the bottom, do the same thing on the top. All right. I'm going to run out of time, so I'm just going to, here, let's just do it real quick. Negative 123 over 24 plus 92 over 24. Rule step, minus 123 plus 92 over 24. 123 negatives and 92 positives. Remember, start at 92 and count to 123. And what's left are negatives. And so that's negative 31 over 24. Would we convert this back to a mixed number? And why would we? Because we had two mixed numbers to begin with. Exactly right. So this is negative 1 and 7/24. If you don't know how to do that, we've already worked on that. So that should be something that's review. All right. Now, if I had time, I'd go back and review everything, but we're out of time. So you've got your notes there. You can go back and look.